Welcome to another episode of How Many Tabs Are Open on Mr. Johnson's Computer, Friday edition 246. Looks like I have two tabs that are open at the same thing, so maybe I should close one. All right, so you have an assignment today where we're looking at a table and a graph, and you're trying to figure out how these things are the same, how these things are different, and then use all four stems to receive full credit. All right, so what we're going to do is we're going to take a look at this. As you can see, our input-output table today looks a lot like the ones you saw in like second grade, third grade, fourth grade. The only difference is they put the letter X on the inside and the letter Y on the output side. So remember, X is your input, Y is your output. They're putting both there now that you have that kind of knowledge that the X and Y also have to do with the X axis and Y axis on your graph. All right, so I'm going to go ahead and I'm going to make this table look like a fifth grade table because I think that that will be a little bit easier for us since that's what we've been working with this whole time. So we have, ooh, they are giving us one of those ones. They are really testing y'all today. All right, so your rule on this one is tricky. So I'm glad you're here watching the video because this is a doozy. Your rule on this one, if your number is getting smaller, you would be like, that's subtraction or division. Here's the thing, you don't know how to do subtraction or division when it comes to finding rules. So the only other way to make a number smaller without using subtraction or division would be multiplying times a decimal. So multiplying times a decimal. That is quite the exercise for fifth grade. So here is our origin once again at 0, 0. And then of course their graph. I'm not going to copy their graph because their graph is perfect and it goes to 11 on both sides, and that's going to be really hard to draw over here. So we're going to reference the graph on this side, but I did want to make the table look like a fifth grade table. All right, so as you notice, your X is bigger than your Y. You probably will never see this in fifth grade again. I have no idea why they're doing this right now, but if you're set for like you're like, oh, I want to think about sixth grade, seventh grade, I would say that this problem is a little bit sixth grady to me. All right, so let's take a look. So we have 4 and it turns into 2, 6 it turns into 3, 8 it turns into 4, 10 it turns into 5. All right, so the only way to make a whole number smaller without dividing or subtracting is by multiplying times a decimal, like a decimal number. All right, so multiplying times a decimal number. So let's think about this. All right, it's been a while, so obviously, if you did not see this pattern to start with, it's okay because we have not multiplied times decimals in a while. Let's just remember this. All right, so 4 times 0 equals 0. 4 times 1 equals 4. So if we multiply times something that is between 1 and 0, we should get an answer that's between 0 and 4. 2 is somewhere between 0 and 4. It's actually halfway between 0 and 4. So if we multiply 4 times 1/2, what will that give us? So let's check it out. Let's try and do 4 times 1/2. Remember, it basically just looks like a math fact. 4 times 5 is 20. But remember, you have one decimal place in this problem, so we need one decimal point in our answer. So if you'll look at that, that's the same, right? 4 times half is 2. So this is where it's kind of weird, because if you're thinking about it, you're like, multiplication, my number got smaller. But remember, ever since you learned your zeros facts, multiplication made numbers smaller. Multiplying by 0 made every number smaller, right? Except for 0, it stayed the same. But 4 times 0 is 0. 1 times 0 is 0. You're multiplying, and the number is getting smaller, right? When you multiply by 1, the number stays the same. So multiplying by somewhere between 0 and 1 should give you an answer between 0 and the number itself. We're looking for an answer that's between 0 and 4 because we're looking for 2. So by multiplying 4 times a number that is smaller than 1 but larger than 0 allows us to shrink our number using multiplication. So let's test this theory out again. Let's do 5/10 times 6. which is our next data point, right? 5 times 6 is 30. 1 decimal place means we move the decimal point over 1. So we got 6 times 5/10 did in fact equal 3. All right. Remember the decimal point and the 0. You can take it off if you want to. It's easier to look at that point, right? So what we're finding out here, let's try the next one. 8 times 5/10. What we're finding out here is that we are actually getting a rule with a decimal. All right, 8 times 5 is 40. We have 1 decimal place, so we move the decimal point over 1. 8 turned into 4. And then finally, let's just do 10 times 5/10. 5 times 0 is 0. 5 times 1 is 5. All right, and then we have 1 decimal place, so we need 1 decimal place in our answer. So it worked. So our rule is a multiplicative rule. It is x, or actually, let's 5/10 x equals y. All right, I did the box just so we could kind of see it like that. But remember, all you would have to do, 5/10 x equals y. Okay, 5/10 times x. You could do it like this: 5/10 times x equals y. All right. Another way that you could write the rule would be 5/10 times x equals y. Just remember, y is the output, so it's by itself on one side of the equal sign. X has a friend. It's either hanging out and partying. It adds or multiplies. All right. So now let's look at the graph. Let's see if the points match, right? So we need to run 4 on our x. Remember, input is run, output is jump. All right. So they ran 4, jumped 2. Ran 4, jumped 2. We have a point that matches our first data set, 4, 2. 6, 3. I need to run 6 because it's my x. 1, 2, 3, 4, 5, 6. And then I need to jump 3 because it's my y. So 1, 2, 3. That matches 2. Next one, 8 input. 1, 2, 3, 4, 5, 6, 7, 8. Run on my x. And then jump 1, 2, 3, 4 on my y. There's that point. All right, on this one, I'm going to run 10, jump 5. So run 10, jump 5. There's the point. So we just found out this table matches this graph. So that's going to be pretty good for they are the same. All right, so what we've figured out is we have a multiplicative rule where we're multiplying times half, or 5/10, because all of these numbers are halving, right? Half of 4 is 2, half of 6 is 3, half of 8 is 4, half of 10 is 5, right? So what we're looking at is we're multiplying times half. So your rule was a multiplicative rule, and it was 5/10 times, or 5/10 x equals y, or really 1/2 x equals y. That would work, because if we found half of 4, it would still be 2. So either one of these, if you wanted to use the decimal version of half, 5/10, or if you wanted to use the fraction version of half, 1/2, both of those work. And remember, if you're wondering why those things are the same, 5/10 is a fraction, is the same thing as 1/2. And remember, 5/10, you could say it either way. You say it exactly the same. 5/10 fraction, 5/10 decimal. 5/10 fraction, 5/10 decimal. So 5/10 fraction is half, and 5/10 decimal is half. All right. So I notice we have a table that looks like a third or fourth grade input output table, except for they added x and y onto our input output machines. I notice that we have a table and a graph. I noticed that we have input and output machines, and I notice we have a graph. There's a lot of things to notice. They are the same. They represent the same data. Our x and y values are the same on both the table and the graph. Our x and y values are the same on both the table and the graph. 4, 2, there's 4, 2. 6, 3, there's run 6, jump 3. 8, 4, there's run 8, jump 4. 10, 5, there's run 10, jump 5. They match, so they are the same. They are different. The left is an input-output table. The right is a graph. Remember, tables and graphs work hand in hand, but they are very different because this is harder to see the pattern on. With this one, we can see that the pattern is going up. As our x gets bigger, our y gets bigger. And then finally, let's see, my rule is we establish that we have a multiplicative rule, because our rule was half x equals y, either in the decimal form or the fraction form. So y'all are getting a head start into some of the crazier stuff. I don't think that you'll see examples like this in on like a fifth grade standardized test or anything. But if you do, you now have this in your tool belt. But usually, it's going to be a lot. You're going to deal with whole numbers a lot more. But here is a example where they did give you a decimal or a fraction to work with your input-output machine. So in fifth grade, if your number from your input gets smaller, remember, you can make a number smaller with multiplication. You have to multiply by a decimal, though. All right? So I hope that that helps you complete this assignment. Don't forget to do your quiz. Um, I think that's it. Thank you for all your hard work this week. I hope you all have a wonderful weekend. Like and subscribe if you feel like it. Talk to your teachers if you have questions. And we'll see you next week. I'll see you later. Bye.